So this is going to be 90 minutes of physics lecture condensed into 5 minutes, give or take. I.e. it's the ideal gas equation and its derivation. Please take it with a grain of salt. Okay, first of all, we have Boyle's law. What Boyle did is he plotted the volume over the pressure. Okay, so you have the volume of a gas over the pressure of a gas in a graph, and this gives us an exponential graph. Of course, it's not quite useful. So what Boyle then did is he took the inverse of the pressure. So he would plot the volume over the inverse of the pressure, and I mean you'll get a linear graph from that, which you can use. So we know that volume is inversely proportional to the pressure. Next is Charles's law. What Charles did is he plotted the volume of a gas over the temperature of a gas, which is already in a linear equation, so we can use that. So we know that the volume is directly proportional to the temperature of a gas. The last thing to remember, the last step or the last ingredient in the ideal gas equation is Avogadro's law. Yeah, there's a law, there's not just a number. Basically what Avogadro did was he had a gas, and he said if you have a specific volume of a gas, okay, and you keep the pressure and the temperature steady, then you will always have the same number of particles as long as the volume stays the same. So we can say that the volume is proportional to the number of particles as long as at STP, okay? Now to sum up, we have Boyle's law. Boyle's law was the inverse relationship of volume and pressure. Then we have Charles's law. Charles was a direct relationship of volume and temperature. And Avogadro's law just had at STP, you can say that volume is directly proportional to the number of particles. Now we can put all those laws together, all those relationships together, and what we arrive at is the ideal gas equation in a little different order, sort of. So we can say that V equals some sort of constant time product of the number of particles and the temperature over pressure. And we can then solve for PV, pressure times volume, to get our ideal gas equation.